Okay, so the next type of sampling we're going to look at is systematic sampling or systematic random sampling. And as the name implies, there's a systematic way that we're going to sample people. So say we have a bunch of people here waiting in a line to get into the emergency room, and we want to measure something on them. Let's say their blood pressure. And so we could do a simple random sample in which we would, assign each one of these people a number. So this would be 1, 2, 3, 4, 5, all the way to whatever this is, maybe 20, and say that we are going to pick random numbers from 1 to 20 until we get to our sample size of, let's say, 8. And so we'd pick this one, and this one, and this one, and then this one, and then this one, and then this one. And this kind of random method, it could work in this situation, but there's another way we can do it. It's called systematic random sampling. And so again, we would number all these people, and then what we would do is we're going to take every fourth person who comes in. So that's a systematic portion of it. So if we took every fourth person, we'd say 1, 2, 3, 4. We'd take this one. 1, 2, 3, 4. We'd take that one. 1, 2, 3, 4. We would always get the same people, right? If we start with this one, 1, 2, 3, 4. 1, 2, 3, 4. So that's not random. So the random part comes in selecting the starting point. So since we're going every fourth person, let's pick a random number between 1 and 4. And so our random number generator says 3. So we're going to start with the third person. So in this case, what we're going to do, our random spot that we're going to start on was a third person, right? And then we're going to pick every fourth person after that. So we'd say 1, 2, 3, 4, right? We'd probably take, hold on. I messed that up. We'll start with the third person, so we'll take that one. Then we'll move to 1, 2, 3, 4. We'll take that person. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And so we would randomly pick the starting point, but then we would systematically pick people after that. Now, where this becomes problematic is if there's some periodicity, meaning there's some repetition within our population. So let's say in this scenario, instead of picking every fourth person, let's take every fifth person. Okay, so we'll randomly roll the dice, and we say we're going to start with the second person. Okay, so that's the first person we're going to pick, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. So what happened here? If you actually look at this guy looks exactly like this guy, looks exactly like this guy, looks exactly like this guy. They're, first of all men, right? We didn't get any women because of this, and they're actually all the same looking person. So that periodicity leads to problems. Let's look at it in a different way. Say we have a street here, and we wanted to randomly sample people on this street for their income, and so we're going to go by house number. So this side of the house is this side of the street's even then odd, even then odd, even then odd. That's common convention with how houses are numbered. And so we randomly choose. And what also is different between this street, this side of the street, the rich neighborhood, is green for the money, and purple is for the poor neighborhood. So they don't have the money. So you randomly select a number, and let's say the first house we select with this is this, and we're going to go every second house or every fourth house. So we go 1, 2, 3, 4. We'd get that one. 1, 2, 3, 4. We'd get that one. 1, 2. So again, look, there's some periodicity here, and so we're only getting the houses on the rich side of the street, and we're totally missing all of these houses. We're not getting those at all. Another example of this is when you're at the airport and you're waiting in line through security. The TSA agents will swipe your hands to see if you have any bomb residue on your hands, and they use systematic random sampling there. So they'll swipe the hands of every fifth person or sixth person, and they should be randomly picking a starting point. Somehow I always seem to get selected for that, but I don't know what that's about. But that's also systematic random sampling. As long as you randomly pick your starting point, that ensures that there's some randomness and everyone has the possibility of being chosen. And so we'll all commonly see this, picking every fifth patient that presents to the emergency room or every 12th patient that's admitted to the hospital as one way of achieving a sample.